In this video, I'm going to go through how to multiply rational expressions. And we're going to start with how to multiply fractions. So you don't need a common denominator to multiply fractions. You just multiply the numerator times the numerator and the denominator times the denominator. But then we want to try to simplify. So we need to look for a common factor that these both share. So for the first one, you can see that they're both divisible by 3. So we can reduce this to 5 over 16. And now that would be a completely simplified answer. However, we could have simplified at the beginning. If we look at the cross numbers, 3 goes into 12 4 times. And 3 goes into itself once. So if we do that first, it makes the multiplication a little bit easier. Now we just do 5 times 1 and 4 times 4. And we get the same result. Okay. Here's another expression now that has variables in it, and we want to try to do the same thing. Again, you could just multiply everything together. 6 times 3x squared is just 18x squared. And 12x times 9 is 108x. Now, this becomes much harder to simplify if you can't tell the common factors. 18 and 108, if you just divide them by 2, you can kind of work from there, but there might be something else that they share, and this is very difficult to tell. So there's a better way if we go down here and we just try to cross cancel first. So to make things easier, 3 goes into 12 4 times again. We just did that before. And 6 and 9 share a common factor of 3. So we can factor that out. And now the x squared and the x also share a common factor. If we divide x squared by x, we just get x. So that 1x is going to stay up there. There's even more we can do. If we see numbers that are on top of each other, like 2 over 4, that's just 1/2. So this 2 can cancel into a 1, and this 4 can cancel into a 2. Now we're done simplifying. We can just do 1 times x and 2 times 3. Okay, so that means back up here, that means that 18 goes into 108 6 times, which is pretty hard to tell. And then, of course, x squared divided by x is just x. 18 times 6, let's just check. That's supposed to be 108. 8 times 6 is 48. 6 times 1 is 6, and then plus 4. Yeah, so that's why I think the second method is going to be easier, especially to do in your head. Okay, so then we'll just do some more examples together. Here, I'm going to cross cancel. Look for things that I can cross cancel. 4 goes into 16 4 times. Y goes into y to the 4th 3 times. This is going to cancel one of those out. 2 goes into 8 4 times. And when I cancel these, they're going into themselves. So there's a 1 there. And then x divided by x is 1, and x squared divided by x is x. So now all that's left is 4y cubed, and then we have a 4x. And now I notice I had this 4 divided by 4. It completely cancels out, and I get y cubed over x. There's nothing left to simplify. Next one, it might be tempting to distribute this, but really this is the opposite of what we want to do. It's already been factored for us, and we just want to look for common factors. This x plus 2 is the same as this. The reason we can do that is because these factors are multiplied together. And then x squared divided by itself is 1, and x cubed divided by x squared is just x. So now all that's left is 2, this 2 times this x, and we just have x minus 2 on the bottom. And there's nothing left we can do because of the order of operations. this division comes last. So if we try to cancel anything out, we're going to be doing the division before this multiplication and this subtraction, which really comes first. So it might be tempting to cancel out and say something like this, x divided by x and 2 divided by 2, but then really there's not much left. There's just this minus sign and some ones. So you might think it's like equal to -1, but that just doesn't make any sense. So 2x over x minus 2 is our final answer. Next one. Now, we can't cancel anything unless we factor first. Before in the previous example, we had factors, the parentheses, so we have to do that. Top left, we have to undo the distributive property by dividing both of these by 2. Okay, and now I can see on the bottom, I can actually cancel that out now. Then on the top here, this is a quadratic, so I'm going to factor it. Two numbers that multiply to get 8 and add to get 6, so that's the sum. Product looks like this, x plus 2 times x plus 4. And I've got another x plus 2 on the bottom that I can cancel out. And now all that's left is 2 times x plus 4, which is 2x plus 8, which would be our final answer. Another one, different type of factoring here. We can't factor this one because 2 doesn't go into 5. But this one here, 4 goes into 8 twice. So we can undo that distributive property. And I'm going to go back and just rewrite the 2x minus 5 here and the x plus 2 here. And then this type of factoring, notice these are perfect squares. So if I take the square root, I get 2x minus 5, but then I have to multiply it by 2x plus 5. So then we have, if that kind of factoring doesn't make sense, go back and watch the video about a difference of 2 squares. This was section 5.4. Okay, so then we can cross cancel. Let me get a different color here. X plus 2 and x plus 2, and then cross cancel 2x minus 5, 2x minus 5. So all that's left is x over 4 times 2x plus 5. So I'm going to write it like that. The 4 doesn't matter if it's behind it or in front of it, but now I need to distribute the 4. So 4 times 2x is 8x, and 4 times 5 is 20. And now I'm done. The last one, we've got a lot more factoring to do here. So the top, we can factor 2 numbers that multiply to get -20 and add to get 1 would be -5 and 4. And then this is this square root type of factoring, x minus 4, x plus 4. And then this one, top right, 2 numbers that multiply to get -8 and add to get -2 would be -4 and +2. And then 2 numbers that multiply to get -10 and add to get -3 would be -5 and +2. Now we can get out our canceling pen. Look for things across from each other. X minus 5, x minus 5. X minus 4, x minus 4. X plus 2, x plus 2. X plus 4, x plus 4. So all that's left, these all divided by themselves, so there's just going to be 1. This expression is actually just equal to 1. No matter what value of x we plug in here, we could take some number like 3. 3 squared minus 3 minus 20. And then do 3 squared minus 2 times 3 minus 8. Do 3 squared minus 3 times 3. Just plug in a 3 everywhere you see an x. And if we actually simplify all of this, it's going to equal 1 every time, no matter what number I plugged in for x. All right, so that is it for this video. Thanks for watching.